Hello students, you're welcome to Biology Lectures with Akerele Olademiji Philip. On today's edition of the lecture, I'll be looking at standard deviation in the calculation aspect with variation, elevation, and the likes, studying population sample and the likes. So today we'll be starting with standard deviation. Afterwards, I'm going to be doing t-test basically. So to start with, because if you don't understand standard deviation, you might not be able to understand or carry out a t-test, because there can be a t-test without standard deviation. So standard deviation measures the spread of data around the mean value. So it means that you have collection of data, basically different values like that. Then you have to find the mean and compare the mean with each of the value. You're trying to know how far each of the values from the mean. What I'm saying is, like we have on this other end here, on this part here. Now we have different values. So if we can get the mean of everything here, they were meant to compare each of these value, I mean the 12, the 10, 15, with the mean. That's what standard deviation is. All right. So basically, let me take you through the things you need to know here. Now it says the standard deviation measures the spread of data around the mean value. A low standard deviation indicates that the value tends to be close to the mean of the set. All right. So that means if standard deviation is low, that means that this value is closer to the mean. I mean, each of those values is closer. While a high standard deviation indicates that the value are spread out over a range, so to say. Right. Now, it's very useful when comparing consistency between different data sets. You just want to know how consistent the data are. Is it too far apart? Are you having something, you're having like 2 as a one of the values, that you have 100, that's too far apart. Now you need to remember this formula. Well, for the good news is you'll be given this data, so you'll be given this formula in exam. If for OCR, you'll be given this formula. You're gonna have the data available, but there's nothing wrong in you understanding in each of this, and if you can just remember it. So this is the formula. Of course, you're going to be provided with the formula, but it's not bad if you can actually know this whole thing by yourself. Like, it's fine. So here it says, okay, we have each of these. You need to remember what each of these things means. The first one there, which is that sigma, that represents summation. So it's like sum of, that one means sum of, all right? Then the x here, this first one refers to each of these data like that. That's what that x means. Then x bar, which is this second one here, refers to the mean, like adding all of these guys together and dividing it by the number of these guys. I'm going to show you that as we move on anyways. Then afterwards, we have n. N talks about number of observations. That means 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 in 3 places. That's 15. So the number of observation is 15. That means n is going to be 15 in this instance. Please, just talks about the number of values we are given. So to say, of course, the s means the standard deviation. Now, there are steps you need to remember when calculating standard deviation. The first step to do is to calculate the mean. So we are going to be doing that with this. I'm going to execute these whole steps by using this example on this side here. So you might want to try this out also yourself. There's nothing bad if you do that. So the first step, so let me write step 1. It says 15 mice were timed how long it took to explore an open field task. This is one of the tasks we do in neuroscience. For those that, it's one of those things you use to test for memory, test for aggressiveness and different things, testing drugs on different, on mice basically. But that's not the talk for today. So basically here, you're meant to attempt this by yourself, like I always told you, then you can always play the video. So step one is to find the mean. So the mean is going to be, so that's going to be X bar. So it's going to be, you're going to add all of these together. So I want you to do the same thing where you are there. I'm going to bring out my calculator here now. So for me, we have 12 plus, so you should do the same thing, plus 10 plus 15 plus then we have how many of these we have? 1 2 3 4 5. Sorry, 1 2 3 4 5. Yeah, so that means that 5 in 3 rows, that's 15. So that's 15. So divided by 15, so 205 divided by 15 gives us 13.66. Now I want you to pay attention to something here. It says here, okay, so the first thing is we've calculated, we had 0.66666 and blah 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 like that. So but what we have here, it says round off to a 3 significant figure, so we might just stick to 13.7. So our mean, let me keep that here, our mean is going to be 13.7. The next step says find the difference between each value, which is x, so each of this is x, and the mean, which is this. So what we're going to be doing is this. You're going to have a table like this. This is x minus x bar. So this sorry, that's not straight enough. Okay, now what we're going to be doing is this. Okay, this is quite long. Let's see how we can make this work. Sorry, I'm trying to make sure everything. Okay, sorry, the line is not very straight. I'm not using a ruler. So each of these data now we're meant to represent that here. So yeah, we have 12 minus 13.7, 10 minus 13.7. You should do the same thing now. 15 minus 13.7. Is that 15 written? Okay, 15. Then what's the next one? 14 minus 30.7. Then sorry, this is 14. 14. Then 17 minus 13.7. Then 11 minus 13.7. I want you to do the same now. You can just pause the video. Statistics most times takes real good time, really. So let me bring this here and extend that. So 12 minus, so let me get that off. 12 minus 13.7 is going to give us 1.7. So 1.7. So that's going to give us minus 1.7. Don't worry about the minus yet because you're going to square it. So when you square it, the minus is going to be out. So the next one is 10 minus 13.7. That should give you minus 3.7. Then the next one is 15 minus, that's going to give you it's going to give you 2.3. Let me try it out. 15 minus 13.7. Are you serious? 1.3. So 14 minus 9.3. Now that's a lot of work, like I told you. So the next thing is, let me get that off for the moment. The next thing is, so we've done step 1, step 2, step 3. So step 4 is to square that. So now we have that way. So we are going to have each of the parameter minus x bar, which is squared. So that means each of the answers you have from there, 0.7 squared minus 3.7 squared minus, so that's not minus, that's squared. That's going to be 86.49. Woo! Yeah, that was quite some calculation. So now we're meant to add that together. So we're meant to find the summation of each of the data squared, like that. So the answer now. So that's some serious calculation again. So we have excuse me, it's 86.49 plus 5.29. Sorry, I'm just starting from the rear. You have to be careful at this point. You have to concentrate. 28.09. All right, so this gives us 280.95. You might want to do that again. I want to believe that that's correct all the way. Really, you might want to rewind the video, really. But this reason why you have to be very careful, because any mistake made here is going to reflect in your answer in the long run. So let's look at the next step now. So the next step says, so we've done this. So it says get the total of the difference between. So we've done that also. Divide the total by n minus 1. So this is where we are now. So we have summation of x minus x bar squared over n minus 1. And so let's do that now. So we have 280.95 divided by 15 minus 1. Yeah, because this n means the number of data, like, so we have 15 here. So let's check that out now. Where's the calculator again? Okay, we have so that's 15. That's going to be 280.95 divided by 14. So let's do that now. So 280.95 divided by 14, and that gives us 20.006. That could be 20.1 when we approximate that. Okay, now, so that means this is the answer for this here. Like, I mean, this whole thing, this is the answer here. So we're meant to find the square root. It's going to be like this. I'm saying summation of x, sorry, that's rough, over n minus 1 all into square. Sorry, that has to be rough, like that. So that means, so what we have here is 20.1 So let's do that now. A few seconds. Okay. So 20, excuse me, it must be this way. The square root of 20.1. And that is, so our final answer is our standard deviation is equal to 4.48 or 4.5. All right, so you might want to go over this again. These are the steps. Actually, I didn't write out. So this is like step. Let me take this off so you can take note of. This is step 1. So finding the mean. This is step 1. That's finding the mean. Then step 2 is getting. Okay, step 2 is getting the significant figures anyways. So step 3, which is this one here, like that. So let's say that's step 3. Step 4 is getting the square root, or that's step 5. Okay, that's step 4. So step 4, getting the square root. Step 5 is the total. So this is getting this total is so this is step 5. Step 6 is dividing it. So this is step 6, this one. So this is step 6. Then step 7 is getting the square root. That's step 7. And of course, this is your final answer here. So you might want to rewind the video to go over this again, and you might still have to write these steps down on this particular page here. Hope this has been helpful in one way or the other. Thanks for being with me. So the next video is going to be on t-test. Do have a wonderful day. Bye-bye.